Okay, hey, welcome everybody. Today, I have a special guest in the studio here where we're going to talk about, LIDAR, in the professional space. You know, in this day and age, LIDAR is being used for a whole myriad of purposes, whether it's small shops or large engineering firms, and it really is growing in what it's being used for. But in this showcase, we like to show, our thought leaders and our folks that are really innovating using LiDAR technology. So today I've got a special guest coming in from Dean Evans and Associates, and I want to introduce Evan Radford here, who is their chief pilot that's doing a lot of these projects for them. And so let's welcome her onto the show here. So, hey, Erin, how you doing today?
Oh, I'm doing well. Thank you, Dan. I appreciate that. Like Dan said, I'm the chief pilot for David Evans and Associates. So started out as a helicopter pilot, but I worked at an engineering firm for my college job, and so just kind of fell into the lidar realm. My previous firm bought a drone and said we need to have lidar. And what they were into at the time was they were heavy into stream restoration work, and they were very interested in getting a lot more detailed topography to do proper hydrological modeling. And so they felt that drone-based lidar was definitely the right tool for the job. And at that time, that was the Section 333 days. We didn't have Part 107 yet. You needed to be a rated pilot. So they gave me the tap on the shoulder and said, "Hey, do you want to run this program? You want to take it and go with it." And I'd never even flown a drone before, but
Yeah,
I
isn't that
said,
funny how
jumped in
that
with both
works?
feet a little bit, yeah. Like, well, I can probably do it. So I bought a drone and spent a lot of time in my backyard and learned all I could about lidar. And yeah, we were off and running, and it really, really changed the business to do it that way. It was so impressive the level of detail you could pick up on these sites. They just the project engineers said that completely changed their view of hydrological modeling, and how they would
Excellent.
address these sites. So
Well, great. Let's dive into that in a few minutes because, I mean, I know our folks are going to be really interested in the wealth of knowledge you're going to bring today. Um, so with that, let's transition first. Who is David Evans and Associates? Who do they serve, and why should we care? I mean,
of
we
course you
care,
should
but
care. We're
but
amazing.
I know exactly. That's why you're here. So,
Yeah.
can you
So
tell us a little about you guys?
it's a pretty broad firm. It started out as a survey firm. Now we do survey and engineering. I'm in the geomatics department, so all about mapping. That's I kind of get tunnel vision. That's all I do. But David Evans itself has a pretty broad structure. A huge transportation unit. Serve a lot of energy clients. They have an impressive environmental division. Can't go without mentioning our marine services department. They run some pretty heavy tools. Big ships, lots of offshore work. So it's a pretty diverse company, and I'm probably ill suited to speak about what the other departments do. I kind of just do this geomatics thing.
Yeah, but the geomatics serves a lot of what they do anyway. So this
We
is
really do. We support a lot of other units. So yeah.
all right. So with that, obviously very broad, it's very impressive portfolio that you guys, when I was looking at your website. Um, but with that, obviously we're here to talk about mapping and more specifically LiDAR. So could you kind of highlight, even though this is for Phoenix LiDAR, I think it's important that everybody knows the breadth and depth of the LiDAR that you're actually using in this day. So what are you using in your projects? Can you give us a kind of a snapshot of that?
Yeah, so I mean, obviously, we're excited about our Phoenix LiDAR unit. We've got the VUX 120, so that's our aerial system. We're running that on drones. We're also running it off of helicopters to serve some of our larger energy clients.
Right.
We have a Regal mobile scanner. I think it's a VMQ, like the
Hmm.
HD1A maybe.
Hmm.
So I mean, we run our mobile unit all the time for transportation projects and pretty regularly for energy clients, doing power line routes that run along roads. I mean, why
Hmm.
wouldn't we? It's such a good way to scoop up lots of data. And then we have a pretty robust catalog of static scanners. We just picked up a Regal 600i. I think it's the VZ 600i.
Hmm.
But we have a really good stable of Leica scanners and Trimble scanners as well. Uh, so we tend to throw a lot of LiDAR at projects. I mean, we love the data. All these data sets mesh well. I mean, yeah,
Excellent.
you can't resist using it once you start using it. It's like, well,
Gotcha. Well, so as we had spoken, you guys were doing mining, you do utilities, you do obviously the environmental restoration, and so what we're going to talk about today, I think, or what we'd like to talk about today is transportation. Um,
Absolutely.
which is, out of all the industries, I mean, they all have their different facets, right? I mean, whether you're just doing typical land survey or what you're trying to do in environmental or even the standards for utilities. But it really seems like the DOTs really have such a high data standard when they talk about the quality of the data that they're looking for. So
Mhm.
could you kind of highlight on how you use your whole portfolio of LiDAR systems to kind of get her done?
Exactly. Yeah, no, it makes sense. You do raise a good point about the level of accuracy needed. It is very serious. I mean,
Yeah.
when you're doing even just quantities for pavement, when you think about a road being crowned and sloped and going along a whole corridor, I mean, if you're infinitesimally off, you're going to
Hmm.
muff the quantities. And then you think about all the bridges, overpasses, exits. I mean, as soon as you're doing any kind of elevated structure, you need right down to the button accuracy. I mean, it has to be right.
Hmm.
So the accuracy is a big deal. Whether we prize that in all of our systems because we have to. That's what the client needs.
Right.
Um, so as a standard, I mean, obviously it's a transportation project. We're going to drive it with our mobile unit. Why wouldn't we?
Right.
And our poor guys are going to crisscross it. Hit all the overpasses, the exits, under the bridges. They're going to go everywhere. Um, but then when you do have something, an impressive structure, overpass, you're going to want to get in there with your static scanners and really pick up all the details that are there. Something that comes up a lot, utilities get hung under bridges and under overpasses all the time.
Hmm.
And sometimes some of this infrastructure is pretty old. We just found a gas line that's completely out of spec for modern regulations.
Oh no.
Nowadays it never would have been hanged under that particular bridge. That's the kind of detail that you want to pick up. So of course we're going to deploy our static scanners, and get those tight tolerances that we need in the dense data that reveals sometimes
Yeah.
hidden, completely undocumented utilities that it would be good to know about before you went and ripped down that bridge.
So, I used to do a lot of stuff like with Caltrans and those kind of folks, and obviously the mobile scanner is their go-to in the statics. Uh, but why a drone lidar or why a helicopter system on a transportation project? I mean, I think
Well,
some
I
people are going
mean,
to have some questions, right?
as much as we love our mobile scanners, and we do, man, the data is tight, it's glorious, it's dense, but there's just you're limited in what you can get from the ground. Our
Hmm.
particular system, we have a boom truck. We
Yep.
can run it at 8 feet, 10 feet, 12 feet. But if you get on freeways, you're gonna have to lower that boom down a little bit to drive at
Hmm.
speed. And even at 12 feet, there's going to be shadowing. If you have a guardrail, if you have jersey barriers, if the road you're on is elevated, if the road beside it is elevated, there's all kinds of different circumstances that can cause shadowing, which means you just have missing data. You have all this glorious, tight, dense data, and then you have holes in it. And then you go to do your extraction, your vectorization,
Hmm.
whatever you want to call it. Uh,
Right.
you get in there to pull out these details, and you have holes in your data, and it hurts when you've been working with these great sets, and then there's missing.
Well, there's also a business reality to this, right? In that, sure, if you're doing like pre-work or reality capture type of things for or as built, excuse me. Um, yeah, we got the road. Yay, great. But what about the off attributes? If we needed to figure out runnage or, what are the other things kind of off the road space that, an engineering consulting firm like you would want to document as you get ready to start a project?
Oh yeah, that's absolutely a concern. There's so many different drainage issues that you want to capture, and yeah, you can't just be tied in on the road corridor. You're want to go several hundred yards beyond the road corridor, and depending on the particular drainage issue, you might be going up to a mile beyond that corridor. Eye in the sky is going to help you do that. You just need different look angles and stuff. And we found that kind of throwing every tool that we have, static, mobile, and aerial,
Hmm.
that's what gets us the data that we actually need. Well, and you get into a project and realize, well, we're going to have to identify all the overhead utilities when they actually go to do this project. And that's something that's come up when we finally flew some of these projects. Our guys were just working with the mobile data, the aerial data came later, and once we filled it in, they were like, wow, I knew there was a utility pole there, but we only got the base of it, because it was on the periphery of the data set. And he goes, well, now I can tell that it's a three-phase distribution pole, and it's got two guy anchors, and I can see the attachment points right there. I just, yeah, it's amazing the level of detail you can pull out. So
Right. Well, and we had been talking briefly about this, in the pre-interview stuff here. Um, but why? obviously we can catch so much data, and you know, some of us will agree or disagree that you can have too much data, but we know that that's never the case.
Lies
But
and slander. There's no such thing as too much data.
but with that, um, is it cost effective to be flying a high-end lidar system over top of a corridor? What are the cost trade-offs, and more importantly, what are the manpower trade-offs? I mean, what does this enable you to do that you couldn't do with the traditional system or traditional method?
Yeah, speed is key and level of detail, and the safety benefits can't be ignored. A good example we have is 30 miles of road corridor we did in I-15 in Idaho recently.
Hmm.
We did the whole thing with the mobile scanner. Why wouldn't we? And
Right.
then we realized, we had some shadowing. There were some areas missed. And so our extraction guys, did all these little polygons and identified all the areas that our field crew would have to go pick up. And they figured it would take them about a month to do that. And it's not just that it would have been a month of manpower out there in the field,
Hmm.
it's also that it's dangerous to be on the roadway. It really is. And it's time consuming as well. To mitigate that danger, our guys had to put out signs a mile before they were working and a half mile before they were working, and also about like 50 feet ahead of their working, and running light bars and festooned in PPE. And it still just takes one inattentive driver for 1 second, and you have a tragedy.
Right.
And so it's unavoidable. We're going to have people in the road corridor, but we want to minimize that to the greatest extent possible. Um,
Yeah. Yeah, for
and these
sure.
are skilled professionals. We need them doing boundary work and running total stations and picking up culvert, invert elevations. I mean, there's a laundry list of things that our field people have to do. And if I can save them time and make them safer and get the project done faster, I mean, why wouldn't I do it? Of course, it becomes cost effective.
Well, and I think you bring up a really good point here is that, yeah, there is the bottom line, the dollar figure here. But, I think what you're talking about, and correct me if I'm wrong, is we're really talking about, manpower optimization. And it's not about, taking jobs away. That's quite the opposite. It's at least from my background where I grew up in the military, our people were the most important thing. And putting them where they were the most effective seemed to be the right thing. And I think what you're describing really is that, yeah, we can have them stake roads all day long, but where is the real value that we get out of them? I mean, where's that return that they can't
Exactly.
do anywhere else? So I think that's beautiful. Um, did I get that right for you? I know
Oh
those
no,
are my words.
absolutely. Absolutely. I mean, I think that is a misconception in the industry sometimes that, oh, this will just replace ground surveying. It's like, no, I can't even do what I do without people going out in the field, getting good control networks set up and getting aerial targets and ground truthing what we've done to make sure that, yeah, this beautiful, glorious point cloud, is it really accurate?
Yeah.
We have to know. So you're never going to replace the people on the ground. It's just that their time could often be better spent than just getting basic topography. I mean, I don't want them messing around with that. They have more important things to do.
Exactly.
So we're able to advance projects much more quickly because we have our ground crews working on critical path items, that aren't just topography. I can collect millions and millions, hundreds of millions of points, in a day. It's beautiful. Why wouldn't we do it that way? And if you
What
can keep people safe at the same time,
and then you
that's
have
just
this
wins all around.
documented for life, right? It's once you have that scanner go down there, as long as you didn't mess up your baselines, it's documented. I mean, you're not sending a
Yeah.
person back out because they forgot to do a line somewhere along the way. So that's beautiful. Um, One of the questions though that you had showed me a data set a few minutes ago, and one of the things that you had brought out to me earlier, and so we're going to catch the whole audience up here, is um, one of the things a lot of DOT folks worry about with drones is, how do you fly this around a corridor and do good capture of the entire expressway or the entire easement that you're looking at here? Um, are you able, Aaron, to pull up that one data set of uh, the Ranger Ultra that had that one pass, so people can kind of see how big
Yeah.
of a swath we're really looking at here?
Is this the one you were thinking of?
I think so. Yeah, look at that thing.
Yeah, yeah. So this is a recent project that we did for ITD up near
Hmm.
Athol, and it was interesting. I don't know if you can see my cursor on the screen, but I just
Yeah,
did
yeah, I
a
can see it.
pass. Yeah, right along the road corridor there.
So for
you
the
know, and,
folks that
and it,
may not see that, you're putting that cursor right down that horizontal um, road from left to right, and you didn't
yeah,
fly over the road. You were to the side of that, correct?
absolutely. And that's a pretty impressive swath. I mean, well, I actually measured it. That's 1,000 meters. That's an impressive capture. So obviously we got all the detail that we could ever
Yeah,
want or need on this road corridor. But the ancillary benefits, I mean, look at how well we captured things like the high school track came in beautifully. And that's extremely far away from my flight line. All the details we picked up on the building, amazing. If there's ever a question about drainage or about
yeah,
utilities on this site, we have it well captured.
yeah. There's
And
no
I'm
holidays in that at all.
no, and I'm so impressed with the level of detail because, like I said, this is a transportation project. It's just a road corridor. If I was flying for utilities, I wouldn't have flown it at 600 kilohertz. I would have kicked it up to 1200 or even 1800. But
Hmm.
look at that level of detail just on that little comms line. You
Right.
know, I mean, there's no shadowing. There's nothing missing. We could absolutely turn this in to one of our utility clients, and they'd be pleased with the output.
That's
So
phenomenal.
I don't know. I'm so impressed with this
Well,
unit. I mean, I can't get enough of looking at this data. It is just glorious.
well, and what I love, and you've had history, as well back in the day, being a Section 333 pilot, and the lidar systems that are out there versus what we have today.
Oh,
When you look at
yeah.
that data, look at just the intensity, the way you can actually see what is there.
Hmm.
The Vox 120 is obviously a very formidable sensor. Um,
Oh, it really is. The
you know,
detail's just incredible.
and I think we were even talking when we started to talk about accuracy. You were talking about what you use for control. Can you enlighten some of our folks on like some of the things you're using for control because the intensity values were so good?
Oh yeah, I mean these data sets are amazing. In the old days we had to be very very fussy about what kind of aerial targets we chose, just because especially the little discrete systems, uh, regular spray paint didn't really pop if you used it on hard surfaces.
Right.
You'd had to have to get a special reflective kind of target, and a lot of times they were ponderous to set and expensive. And nowadays you can just do regular spray paint. I mean, look at that. This is a flight I did recently.
Mm-hmm.
We hacked the top off of a 5 gallon bucket and just rattle canned it with regular survey paint that we have in the truck anyway, and it pops beautifully. There's tons of points on that.
I mean,
You
long
can't
gone are
argue
the
with that for a
days of the
second.
48 by 48 target.
Right, and I don't miss setting 4 foot panels. We used to do like 4 foot plywood panels. Oh,
Yeah.
that was miserable. Or you get the flexible fabric, which is great. It's not as heavy, it's a lot more mobile, but then you go set that even in like short grass and it's all lumpy bumpy. It's hard to get it all pegged out. You're using 5 different nails. Now
Right.
I'm sinking a mag nail, psh, quick spray. I'm setting targets in 5 minutes. It's easy, it's great.
Mm-hmm.
um and then I don't know, you want me to talk about the the top end aerial target? um People always laugh, but we actually have really good luck with a Chinet 10 and 3/8 inch dinner plate.
That's
Okay, this
amazing.
scanner rocks. I mean, it pops in the data. It looks beautiful. It pops just like that spray paint does. And you can set a paper plate on a hub anywhere. And
Well,
why
and
wouldn't you?
and from a surveyor standpoint, do they want to drag out a large target and set it up, or do you want the aeromat type of thing where you have a couple of these in your backpack and you throw it out, set it, forget it, and you're off to the races?
Yeah,
So, I mean,
exactly.
being a lidar guy, who cares? But being a surveyor, the smaller and the easier we can make this, why not?
Yes, and I mean, if you can get away with using a paper plate, which we can more than get away with it, it pops beautifully in the data. In fact, I have another picture of that right there. This is a cross section cut across.
Uh-huh.
That's a paper plate. I
What's
mean,
the for our viewers, because we don't have scale on this, but how much offset from the surface are we looking at here?
well, it's interesting that you bring that up. So I went and flew this project. I processed in my hotel and I looked at that and I said, why? Why is that ground target off the ground? Because I'm
Uh-huh.
getting great values. The statistics are fine.
Yes.
Um, and I was a little bit vexed. And so I couldn't resist. I was still in town. So I hopped in the truck and went and looked. That aerial target, the ground crew had left the hub 3/4 of an inch high off of the ground. And so that plate was actually elevated.
Oh.
And I picked it up in the data. Yeah, I immediately called the guy who set the target and said, caught you, man. You left that hub a little high. What were you doing? You know, but that's pretty neat. You see something like that in data and you wonder, well, is my data bad? And it's like, no, that scanner is just amazing. It picks up
Yeah.
that level of detail, 3/4 of an inch high, and we could tell. We could
Wow.
tell immediately.
That's
So
amazing.
yeah.
Oh, very
So the ground
cool.
crew got a little talking to about how we like to have our aerial targets set. No problem.
So, as we were talking about all this, and first off, thank you for sharing the data. Some people get nervous showing this, and this is such a help for the whole community because, data matters in this kind of business, and the accuracy matters in this kind of business. Um, but I think what I'd like to touch on, because we're doing transportation and we are doing um, overlaps in here, could you start to show us like what mobile looks like in conjunction with aerial scan or with the Ranger Ultra?
Oh yeah. This is a data set I have. This is mobile and aerial loaded up just in Qt Reader. And if you start looking at the edges of this data set, you actually can't tell that there's two data sets. That's
Hmm.
how well they mesh. Um, Sorry, I probably should have loaded it up in Global Mapper so that I could show you cross sections. Um, but yeah, you wouldn't know it, but this is from two separate LiDAR sensors. This is both aerial and mobile together. And that's how well it meshes. You can't tell.
Oh, that's great.
Yeah, I mean, and in the
So
old
take
days, these data bands would have been really thick, and you definitely would have seen delamination between different sensors.
Yeah.
But as long as you're using good workflows, there's no reason your data sets can't match perfectly, which these
And
do.
correct me if I'm wrong. You're using so this is in you use a myriad of different software. I mean, you have to like that's
Yeah.
just something you do. But for the LiDAR processing for your aerial, you're using Spatial Explorer. And
Mhm.
so how is that? I mean, a lot of the things and some of the folks that may be new to LiDAR may not realize like, you're doing trajectory correction, you're adding in your survey references, then you bring in your LiDAR data. But then there's a whole myriad of things to get, strip to strip to work and what has been your experience, in that workflow, um, as far as like getting good quality data out of that?
So we were really impressed when we first acquired our system. You talked about strip match.
Yes.
That's something that's always been very important in the aerial LiDAR industry. But there's a notorious possible flaw with strip match software.
Hmm.
And anybody who's familiar with processing will understand this. You have that basic bostrophodonic lawnmower pattern that you're going to fly to acquire data, right? So you end
Right.
up with strip, strip, strip of data. And if your data set is maybe slightly imperfect, it's pretty common to see a strip of data like this and then another strip of data like this. They're
Right.
perhaps not quite right at the elevations. That could be because you have inaccurately measured your lever arms. There are many reasons that this could occur. And so to try to resolve that, it's always been pretty common in point cloud processing softwares, whether you're using, Yellow Scan or Spatial Explorer, PosPag, any number of things, to have some sort of strip matching tool. And the Achilles heel of these tools is that when they're matching strip to strip, you can get an ascending error. It's very, very common to have
Yes.
them strip and bias, and eventually you get data sets that curl up at the edges. And so that's very dangerous. And so because we were kind of experienced from previous firms using aerial LiDAR, we were really keen to evaluate the results we were getting from our Phoenix system without doing any kind of strip matching. And then
Right.
we were very keen to specifically evaluate the strip matching tool and see if we could see ascending errors like that, because obviously that would be a bummer. Be
Yes.
a bummer, man. Yeah, very professional here. So anyway, when we first got the system, we did not use the strip matching tool, and we just did a strict data evaluation of the point clouds that it would spit out without leveraging that.
Hmm.
And we were really impressed. I mean, really impressed. We flew it for I think a month and a half before we ever even tried the strip match because we were getting glorious results. They were all within tolerance. Those point clouds were they were beautiful. We didn't even need it. It's like
Well,
strip
that'll make
match.
Ben really happy.
That's something we won't even use. Like, yeah, it's cool, it's there, but whatever. And I mean, we were all excited about our new system. We were flying it all the time. So it took us a minute to even dust it off and try it out. And then we did, and we were very impressed with the results that we got. I really like the way you can do the strip match in Spatial Explorer, because what you do is you build your cloud, you bring in your control, and then you get those residual values and see where your errors are.
Right.
And what we were doing is we were looking at those errors and going, that's nothing. Everything's within tolerance. Why would we even bother? But when you use that strip match tool,
Right.
um, it's doing those strip matches, but it's taking your ground control into account, which is why it's not getting that ascending error. It's saying, oh, I have some other data here that's telling me that I shouldn't move that strip up high. In fact, I should be moving that strip down instead. At least that's my interpretation of how it's working. So you're not rubber sheeting it. You're
Mm-hmm.
not using it as a strict constraint. It's just that when it makes that decision about whether to elevate a strip or to push it down, it's doing that with the knowledge of the ground shots that you brought in. And
Yeah.
that's why it's a much more robust tool. And so what I like to do is I like to do a snapshot of my residuals before I ever run it, then run the tool, take another snapshot, compare the two, and say,
Mm-hmm.
okay, where did we get better? Where did we get worse? And it's such a fast tool. Sometimes, I'm mixing and matching control and seeing, all the different iterations. And the thing is, it's always good without strip match. Strip match brings it down a little bit. You might as well.
Yeah.
If you can tighten it up a little bit, why not tighten it up a little bit? But it's really, really, it inspires a lot of confidence when without doing strip match, it's all looking great. And then you've
Mm-hmm.
just fine tuned it that little bit. So I think Spatial Explorer really has an edge there.
Nice. Well, and I would say that, with that, obviously without or with, obviously you're getting data that is so precise that you're able to integrate that with a road scanner and not see that. That is phenomenal.
Yeah, it's amazing. It's amazing. And if I fly really high and maybe at a lower rate because I was just trying to, do fill in topo, you can see that the mobile scanner data is like just really, really dense, and ours is still really dense, but maybe not quite as dense as the mobile scanner that was only 8 feet from the road,
Well, your beam
right?
is traveling
But
farther.
those,
Yeah.
yeah, it's a little farther. But those two data strips, so there is a visual difference, but they made up perfectly. And
Nice.
that was really how we were able to sell it internally. Because there were people who were understandably skeptics. They've
Of
been in this
course.
industry a long time. They've seen the early days of aerial lidar, and then when we showed them that, they were like, "Oh my goodness, this is amazing!" And then I kicked the data rate up, and it's like, "Wow, that looks a lot like our mobile data, actually." So it's been a real mind changer. It's cool.
Well, we had talked about something last time, and I thought this was interesting in that you had talked about why even have LiDAR on board internally. And um, could you talk a little bit about like third-party LiDAR coming into a project versus, having your own? And what are the
Yeah.
things that, David Evans has actually experienced along the way that's led to this, internal capability and why they're so fervent in having it?
Yeah, I mean, a lot of it is quality control and data density. Good example, we're doing road project right here, right outside my office. And it was really neat. The client came to us. They had gotten some aerial data, some manned aerial data, both LiDAR and imagery. And they
Hmm.
said, yeah, get going on this project. Here's some data to start with. And it was okay. I don't want to say
Hmm.
that it was bad. It's just that as we got into it, we were seeing that some of it was up to 2/10 of a foot off. Not all
Right.
of it, but some of
Right.
it. So that was disturbing. Um, and then as we really got into detail, we realized our designers, they started examining the surface that they built off of this data, or that they had gotten from the third party.
Right.
The surface tinned and completely missed a head wall on an overpass structure. And so
Whoa.
you have this
Whoa.
severe angle instead of this nice straight wall. And it's like, how did that happen? And so we did some detective work and found out that this was most likely, flown by an American company, but probably offshored, to do the surface creation, or
Oh
maybe they
yeah.
used an automated tool. I don't know, but either way, it's
Well, we could
someone
throw
in a
darts
foreign
all day
country with
long.
no context, or it's some kind of AI tool that maybe someone didn't do the proper QC on. But either way, this was a really critical infrastructure detail that was missed.
Right.
And then you've got the maybe this is 2/10 off in places. And so we went back to the client and just said, look, we appreciate that you had this data, but it's inadequate. It's certainly not up to our standards. We don't think it's up to your standards. And they were very amenable to having us really replicate some work from their view, but it just the quality wasn't there. You can't run a transportation project that way. You just can't.
Well, I mean, a lot of the like the lighter quality standards that are generic, like ARSPS, are designed for aerial. And the lighter qualities are 8 points per meter squared, maybe a little bit less. Um, and sometimes you need for a lot of these engineering projects a lot more dense to build something out.
Oh yeah, an engineering design project, 8 points per square meter is never going to do it. Maybe that's appropriate for countywide, statewide topography. Sure, it has its place.
Right.
Uh, but no, not at the level we're working on. I mean, pick the right tool for the job. You need more data density than that, and you certainly can't accept something to be 2/10 of a foot off. That's crazy.
Right.
So that was really the driving force. Is just our clients need better data. They want us to have this tool. So.
And in general, I know this is a moving target as like when we were working on UAS stuff for transportation for California, they were always trying to up the bar. But
Mhm.
for your clients right now in transportation, and let's just stay in transportation for right now, what kind of accuracies are they really looking for, to do some of these projects or these pre-assessments?
For aerial data, I think we're all happy if across the whole data set you can be within 1/10 of a foot, because
Hmm.
that's, if you're out there, guys, just with a rover, that's what they're going to get with their GPS gear. We're not going to guarantee it beyond that, even though you certainly get shots that are better than that.
Right.
As long as we can guarantee the whole data set within 1/10 of a foot, we're good to go. um, and we're confident with the Vux 120 that we're getting that. Um, I would say we're getting a lot better than that. On our targets and on hardscape and things like that, we're seeing crazy values. Like the worst shot I got on my last flight was 300ths of a foot.
Oh my goodness.
That was my most out of tolerance point.
Right.
Um, so we're very, very confident in the level of detail and the accuracy that we're getting. But yeah, as far as what transportation districts want, they seem to be happy as long as we can meet the same standards of your GPS gear.
Excellent. Well, and I
That
think
seems to
that's
be good to go.
important because, as we're talking here, I mean, yeah, we're talking about some specific hardware, but there's some prosumer stuff out on the field today, and it has its place. But when you start to get to this level, and you're trying to match data sets, that relative precision is key for engineering work. And so I just kind of wanted to bring that out or highlight that, because a lot of people don't understand that. Yeah, these pieces of equipment are a little more on the pricey side, but you're paying what you get for, and it enables your business to really excel. And I think that's what we're seeing here is you don't doubt your data one bit, and neither just I'm putting words in your mouth, but I don't think your clients matter.
No, they don't. Well, I mean, and that's the thing. We can prove it. We do the work on the ground to make sure that we can prove out this data. Especially when the scanner was new, we did a lot to prove it. One of our first projects, we busted out the total stations and the static scanners and just went nuts, and moving from the road corridor into the trees with all of these different tools. And then we tested it against our aerial data, and it's like, wow, that's just perfect. I mean, it's just right there. But yeah, I mean, we have standard reporting tools on a transportation project. We're usually going to do 1,000-foot cross sections, and you're moving, on from the periphery of the project across the hardscape back into the periphery. So you're getting good hardscape shots, but you're also getting down in the weeds and the trees and the brush, and it's very nice to be able to check against that.
Well, and I would think, and so a lot of your stuff is doing pre-work, but you're actually getting called back to do, post-as builds, right?
Oh yeah. Oh yeah. I mean, people get a hold of this data and they love it. And like you said, it's documented forever. So when they see the level of detail that we're picking up and the accuracy, a lot of times we're getting repeat customers that say, "Well, will you just come fly our project again at the end? We'll use it for the as built. We'll use it for the documentation." Um, yeah, and people use our data in their marketing too. I mean, why wouldn't they? It looks beautiful.
Right. Well, and it's just a good customer. If they're coming back, you've got good customer relationships. Like you've really set the bar.
Well, it is a relationship business. I mean, we love our clients, so it's
Absolutely.
good.
Absolutely. Um, wow. By the time is really going here. So let's, a couple quick questions after this, and we can go here. But um, one of the things maybe because you've done all these different LiDAR systems, how hard was it to actually get the Phoenix system up and running?
We had an easier time than I think maybe a lot of people would, just because we had one of those situations where a group of professionals kind of follow each other around. So we all ended up back at DEA, got the old gang back together. Um, and we'd certainly been in the trenches with other systems. So it was pretty easy for us, but really speaks well of Phoenix LiDAR. They treat you right. The training is good. The support documentation is good. They're so responsive. Um, yeah, it was just really, really easy to onboard the system and be immediately productive. To this day, one of the largest jobs I've done is the first job I did with this system.
Go big or go home, right?
Right? Yeah. Why wouldn't you? Um, yeah. And I mean, I had one hiccup in the field, one hiccup, but I called, got Alex, on his cell phone because, of course, he gave me his personal number.
Of course, that's the way we do things.
Aaron, call me if you have any problems. And I just said, man, the PLP doesn't look right. And he goes, I know what it is. He's like, you're shutting down the system too fast, and he ran me through everything. And then he's like, and I was like, oh, okay, no big deal. I'll refly it. He's like, Aaron, you don't need to refly it. He's like, that's why we have the backup file, So I got
Yeah,
15 minutes on the phone with Alex. We're back up and running. I didn't have to refly everything because Phoenix cares. They're invested.
yeah.
Yeah. And it really does come through. It makes a difference. I have a bunch of friends in Texas now,
Well, we love having you out this way for sure. Um, okay, and then with that note, this is Phoenix's 10-year anniversary, and so is there anything you'd like to say to them or share with them? Because they're going to watch this obviously with intense interest. But is there anything you'd like to say to them?
Oh gosh, I'd love to just name check all those folks, from Grayson and Rob to Terry and Hannah, and
Hmm.
oh man, and Lito, and obviously Alex and Joel. I mean, you guys have just, yeah, you've really made us welcome. Feels like we're part of the Phoenix family. I
You are.
just can't stress can't stress enough how easy and pleasant they made the whole process of acquiring this unit. And I mean, we can't wait to get it paid off and buy another one. I mean, we just want to do business into the future with you guys because it's been an excellent experience, and it's been an honor to meet you all and work with you, and I sure appreciate it. Here's to
Excellent.
10 more.
I love it. I love it. Hey, so we need to wrap up here now, but um, obviously you guys are doing this work. And if somebody has watched this and said, yeah, I want to do business with David Evans and Associates, how do we get in touch with you, to partner up or do a project or anything like that?
Oh, absolutely. There's a lot of contact information on our website. You can go to the SUAS page and you can find my contact information. Um, yeah, reach out to anyone really. There's a lot of good information on the website about how to get a hold of us. But yeah, you can reach out to me, Aaron Radford, Duffy Haggerty, Daryl Ramus. I mean, anybody at DEA knows to send you our way. So
Outstanding. Well, what I'll do is I'll make sure that, when we post this, we'll have that stuff in the description below. And that way, they can find your website, but then they can also find your business development team as well.
yeah,
So, and
absolutely.
then, inside of that, if this has helped you guys and you have more questions or you want to dive into more aspects around these LiDAR sensors, I'm also going to leave a link down to our sales and technical team that can help you see data just like what you've seen here today and talk about some of the business and technical concerns that you might have. And also if you have questions, leave it in the comments down below and we'll answer those because we're pretty responsive if you can't tell here. So I hope this has served you well. And if you like this, go ahead and hit the like, subscribe, because we're going to put out a lot more of these. The stuff that Aaron's put out has been extremely helpful. This has been a rare treat. And so, Aaron, thank you so much for
Oh
doing
gosh,
this.
anytime.
I know that when I was doing this early on, I wish I would have had this because it's just been huge. You just don't see this kind of wisdom out in the field every day. So thank you so much for coming here today.
All right, thank you.